Hello friends, let's come back and try to assemble a circuit on a breadboard where we are going to make inverting amplifier using OPAMP. Now, the circuit would be a 741 op-amp, output getting connected to the inverting terminal with the feedback resistor RF. We will connect another resistor R1 and we will provide the input at R1. We will connect the plus 12 supply to the pin number 7. We will connect minus 12 to pin number 4. Now between pin number 1 and 5 we will connect a potentiometer and the middle terminal of the potentiometer will be connected to minus 12. So this is our IC 741. This is the output and here we will provide the input. So far so good. We are going to have a split power supply, or we can call it dual power supply. With respect to the ground, it is plus 12, and with respect to the ground, it is minus 12. Now, for measuring the voltages, we will connect a voltmeter with respect to the ground, and with the same voltmeter, we will measure the input voltage. Now, since this is our circuit, what we have to do is we have to get a potential divider circuit which will provide different voltages at the input. Now this can be done using two methods. Either you can use a variable resistor or a potentiometer, or we can use a potential divider circuit which will provide the input. Now let's see how can we build a potential divider circuit and what is a potential divider circuit. Now suppose we have two resistors R1 and R2. A plus 12 volt supply has been connected between the ground and this terminal. This is R1, this is R2. So this is V, and we will have to calculate what is V out. Now how can we do it? See, a plus 12 which is applied here is nothing but a battery having a potential of 12 volts which has been connected across this. Let the terminals be X and let the terminal be Y. What we have to get is the voltage across the resistor R2. Now we have to calculate the voltage with respect to R1, R2 and V. So how can we do it? We'll have to apply KVL into the circuit. Now step 1. If a voltage has been applied across this network, then obviously we will expect a current flowing into this circuit. So let us consider a current that is flowing into the circuit. Let that be I. Now, if we apply Ohm's law, this is V, which is equal to I to R1 plus R2. Now, we are trying to measure the voltage across R2. Now, again, applying a similar concept, that is the Ohm's law, we can see that only I current is flowing through this R2. Hence we can write I into R2. Now rearranging both 1 and 2 for I, we can get is V by R1 plus R2. Similarly, rearranging equation 2, we get equating 3 and 4, we get V by R1 plus R2 is equal to V0 by R2. Therefore, V0 is nothing but R2 divided by R1 plus R2 into V. So, if R2 is equal to R1, then what we get is V by 2. This is what is known as a potential divider. Now this holds true if we do not draw any current in this branch. And since we are using an operational amplifier, the operational amplifier actually do not consume any current for its operation because of its high internal impedance, we can have a potential divider network to give different type of voltages to its input. Now let's see how can we do it. We will apply the similar concept. Now we have a total potential of plus 12 and minus 12, and if we want to divide the potential, we can take a network which can consist of a resistor 10K, then another resistor 1K, and two parallel 1K resistors, making this 500 ohms. So the total comes out to be 11.5 kilo ohms. Now we are still left out with 500 ohms. If we add 500 ohms, the total will be 12k. Okay. So what we can do is we can add up 5 1 kilo ohms resistors. I'm sorry, 500 ohms resistors. So we have 100 ohms, we have another 100 ohms, we have another 100 ohms, another 100 ohms, another 100 ohms. Total is 500. Total is 500 plus 500 ohms. Since both the resistors are in parallel, so when both the similar type of resistance are connected in parallel, it becomes half. Effective resistance becomes half. So it's 500 ohms. 500 ohms. Total is 1k. 1k plus 1k is 2k, and it's 12k. So now if I consider this as R1, R2, R3, R4, R5, R6, R7, R8 and R9, and if we connect a 12 volt supply across this, then applying the potential divider formula rule, V1 will be the drop across this divided by the total resistance, that is V1 will be R1 divided by R1 plus the rest. Let me call that R total. It is 100 ohms divided by 100 and rest will give you 12,000 ohms into 12, which will give you 0.1 volts. So what we will get is 0.1 volts here. What about the next one? This is V2. Similarly, V2 will be R2 plus R1 divided by R2 plus R total. Actually here R total is minus this, or we can just call this R rest. That means total. So if we are writing total, it means resistance minus this. That is why we are writing R2 plus R total. Okay. So what we get here is 200 divided by again 1200 into 12. What we get is 0.2 volts. What about this V3? V3 is R1 plus R2 plus R3, R1 plus R2 plus R3. We will call R total plus the total one, which is nothing but 300 divided by 12,000 into 12, which is nothing but 0.3 volts. Similarly, we will get a 0.4 volts here. We will get a 0.5 volts here. We will get 1 volt here. We will get 2 volts here. So this resistor network will provide me a voltage range from 0.1 to 2 volts. There is another method using which I can provide the voltages. That is, we know we have a plus 12 volt, we know we have a minus 12 volt supply. Just connect a potentiometer between these two, and the slider will provide you the voltage. So if the slider moves towards plus 12, we will get a plus reading here, and if the slider moves towards the minus, we will get a negative reading here. In our experiment, we will choose the resistive network. Now let's redraw the circuit. We have a 10 kilo ohms resistor, we have a 1 kilo ohms resistor, we have two 1 kilo ohms resistor, we have 5 100 ohms resistors. 100 ohms, 100 ohms, 100 ohms, 100 ohms, 100 ohms. We are having different potential points. And this. And this. We can apply plus 12 or we can apply minus 12 with respect to time. When we will apply a minus 12 here, we will get different minus voltages, and if we apply positive, we will get different positive voltages. So we can either have a switch, or we can use simple wire to connect to the different voltage readings, get different voltages at the input. We will basically do this using a simple wire. Now there is another thing that we have to look into, that is offset null adjustment. Now what is an offset null adjustment? We have an operational amplifier and we are making an inverting amplifier. So we have RF, we have R1, we have VCC, we have minus VEE, we have output voltage, we have the non-inverting terminal grounded, we have the inverted terminal in action, and we will connect a potentiometer between (1) and 5, and the slider will be connected to the middle. The middle pin of the slider will be connected to the negative supply. Now this is plus 12, this is minus 12, and before making the connection to the potentiometers, what we need to do is we need to connect this to the ground. We can connect this directly to the ground and check the output voltage in millivolt range. As per the equation, V out is minus Rf by R1 into V1, which is this. Whatever be the value of this, if V1 is equal to 0, V0 will be equal to 0. But even after that, we will see some voltages are available at the output in milliorder range. Those are called offset voltages. Now, if we have offset voltage, and when we will amplify the signals using operational amplifier, we will get an error. So it's better to nullify the offset and then move on with the practical. Now let's start our practical. For that, what we need is a power supply having plus supply and minus. So I have a power supply. As you can see, it is having a common terminal, it is having a plus 12, and it is having a minus 12. We will use the power supply for our experiment. Now, let's have the breadboard. Now, one side of it we will do the circuit, and on the other side we will create the potential divider. Okay, so this is the operational amplifier. Okay. Now we have the common terminal which will be connected to this section. So this entire stretch is 0. Now the positive supply will be connected to the top portion, and this will be taken as plus 12. Now